Introduction to Matrix.
Hi, I am Krizzy J. Balasbas, and for this video, we will have a discussion about matrix. After watching this video, you should be able to first define what a matrix is, second, identify special types of matrices, and lastly, identify when two matrices are equal. What does a matrix look alike? Matrices are everywhere. If you have used a spreadsheet such as Excel or written numbers in a table, you have used a matrix. Matrices make presentation of numbers clearer and make calculations easier to program. Look at the matrix shown. This is the representation of a matrix. As you can see, there are rows and columns present in the illustration. So what is a matrix? A matrix is a rectangular array of elements. The elements can be symbolic expressions or and numbers. Here in matrix A is denoted by this illustration. Row I of matrix A has n elements and column J of matrix A has m elements. Each matrix has rows and columns, and this defines the size of the matrix. If a matrix A has m rows and n columns, the size of the matrix is denoted by m times n. Each entry in the matrix is called the entry or element of the matrix and is denoted by aij, where I is the row number and j is the column number of the element. The matrix for the tire sales example could be denoted by the matrix A as this illustration. Here in the illustration, there are 3 rows and 4 columns. So the size of the matrix is 3 times 4. In the illustration, the size of the matrix A is the number that in the position of A sub 3, 4, which is 27. We will now move forward to the special types of matrices. So what are the special types of matrices? The first one is the vector. A vector is a matrix that has only one row or one column. There are 2 types of vectors, which are the row vectors and column vectors. For row vector, if a matrix has one row, it is called a row vector. And n is denoted as the dimension of the row vector. Here in the illustration, which is the matrix B, it has the elements of 25, 20, 3, 2, and 0. So this is an example of a row vector and its dimension is 5. Next type of vector is the column vector. If a matrix has one column, it is called a column vector. Here in the illustration is the column vector and m is denoted as the dimension of the vector. In this matrix, which is the matrix C, it has an entry of 25, 5, and 6. So this is an example of column vector and its dimension is 3. Next special type of matrix is submatrix. If some rows or and columns of a matrix are deleted, the remaining matrix is called a submatrix of A. For its example, this is the example of submatrix. Here in the matrix A, there is an elements of 4, 6, 2, 3, -1, and 2. For its submatrix, it can be 4, 6, 2, 3, -1, 2, and it also can be 4, 6, 3, and -1, and also matrix of 4, 6, and 2, as long as the number is given in the given matrix. Next type is the square matrix. If the number of rows m of a matrix is equal to the number of columns n of a matrix M is equal to n, then A is called a square matrix. So here is the example of a square matrix. It has the same number of rows and columns, which is 3. The diagonal elements of A are A sub 1, 1, which is 25, A sub 2, 2, which is 10, and A sub 3, 3, which is 7. Next type is the upper triangular matrix. A n times n matrix for which aij is equal to 0, greater than j for all I, j is called an upper triangular matrix. This is the example of an upper triangular matrix. Next type is the lower triangular matrix. N times n matrix for which aij is equal to 0, j is greater than I for all I, j is called a lower triangular matrix. So this is the example of lower triangular matrix. Next type is the diagonal matrix. A square matrix with all non-diagonal elements equal to 0 is called a diagonal matrix. That is, only the diagonal entries of the square matrix can be non-zero. So this is the example of a diagonal matrix. As you can see, this diagonal is only a non-zero values. Next type is identity matrix. A diagonal matrix with all diagonal elements equal to 1 is called an identity matrix. In this illustration, which is matrix A, as you can see, the diagonal which is equal to 1 is an example of identity matrix. Next type is the zero matrix. A matrix whose all entries are 0 is called a zero matrix. So this matrices, which is A, B, C, D, are all example of zero matrix, simply because all the entries or elements of the matrices is 0. Next type is tridiagonal matrices. A tridiagonal matrix is a square matrix in which all elements not on the following are 0: the major diagonal, the diagonal above the major diagonal, and the diagonal below the major diagonal. So this is the example of tridiagonal matrix. Lastly, when are two matrices considered to be equal? Two matrices, for example, the matrix A and B, are equal if the size of A and B is the same, which is number of rows and columns of A are the same as that of B. Here in this example, the matrix A and matrix B, this is equal if the value of B sub 1, 1 and B sub 2, 2 is the same as the value of A, which is the 2 and 7. So that would be all for this video, guys. Thank you for watching, and I really hope that you learned from my video.